Okay, so when we're talking about domain, remember we talked in class that there are some kind of basic rules about domain that we have to consider. So the first is that the denominator can never be 0, that if we have an even root, that the radicand has to be greater than or equal to 0, and that the argument of a natural log has to be greater than 0. So those are basically the three most common restrictions when you're talking about domain. So let's look at this first problem. Okay, so we have a couple things happening. We have a radicand and we have a denominator. So I'm going to take both into consideration. So the denominator can't be 0. So the only thing in the denominator is x. Okay, so x cannot be 0. The second thing is that the radicand has to be greater than or equal to 0. So my radicand is 1 plus 3 over x, greater than or equal to 0. So I need to solve, so negative 1. So I have 3 over x is greater than or equal to negative 1. So I'm going to multiply by x. So I have 3 is greater than or equal to negative x, divide by negative 1, negative 3. So I need to flip my sign, less than or equal to x. So I'm going to rewrite this in the form that we are most familiar with, which is the variable on the left. Okay, so anytime I see a fraction within a radicand, I know that that is a trigger warning, like something can possibly go wrong here. So let's look at our number line. Okay, so let's think about this. So I have negative 3 and 0, right? So I want to check to make sure that what I'm looking at is the solution. Okay, so this says that it has to be greater than negative 3, but it can't be 0. So I'm going to try, say, well, how about 0? So greater than negative 3, but not 0. So let's try something like 1. So if I plug in 1, I get the square root of 1 plus 3 over 1, which is the square root of 4, which checks out, right? Okay, so that checks out. So we know it can't be 0, so let's try something here. So let's try, say, negative 1. So negative 1 would be the square root of 1 plus 3 over negative 1, which would be 1 minus 3, which is a no-go. So this section doesn't check. Now, this says that it has to be greater than negative 3, but anytime I have that fraction, I'm going to check all of my regions. So let's just go ahead here and check negative 4. So I have negative 4. So I have 1 plus 3 over negative 4, which gives me the square root of 1 minus 3 over 4, which is the square root of 1/4, which does check out. Okay, so remember that as these numbers get larger, going in the negative direction, that fraction is actually getting smaller. It's getting less and less and less than 1, so it's always going to be positive. So now we know our sections and we can write our final domain. So we have domain would be negative infinity up to that negative 3. Okay. And we can include negative 3 because I can take the square root of a negative. Union. But notice we can't do this section here, so we're going to pick back up at 0, which I can't include because it can't be the denominator, to positive infinity. Okay. All right, so let's look at our next one. It won't let me go to the next one. Okay, so for this problem, we have then that the denominator can't be 0, so we need to figure out what makes the denominator 0. So that factors, that should be a plus. So I'm sorry, this should be a plus sign here. So then we have x is equal to 5 and x is equal to 1. So they can't be that value. We don't care what the numerator is. So we have the domain then is everything except 5 and 1. So you have negative infinity to 1, union 1 to 5, union 5 to positive infinity. Or you can do set notation, which is x such that x is not equal to 5 and x is not equal to 1. Either one is acceptable. Okay, so tangent, so there's two things to consider with tangent. First, where tangent is undefined itself, and then we also have to consider where tangent is equal to 0 because it's in the denominator. Okay, so tangent is undefined. So for number 1, tangent is undefined. Remember that tangent is sine over cosine, and notice that we have this interval that we're bound between. That way we're not talking about infinite values. So everywhere cosine is equal to 0, tangent is undefined. So cosine is 0 at pi over 2 and 3 pi over 2. So tangent is going to be 0 whenever sine is 0. And sine is 0 at 0, pi, and 2 pi. So it can't hold any of those values. So set notation would be much easier here. So x cannot equal 0, pi over 2, pi, 3 pi over 2, or 2 pi. Now you can do that in unions, but it's just a bunch of unions, so just be cautious. So the last one is, more basic than the first, obviously. Denominator can't be equal to 0, and you also have that the radicand has to be greater than or equal to 0. Now these two can be resolved in one because they're both in the bottom by that the radicand has to be greater than 0. So the radicand can't be equal to 0 simply because the denominator can't be 0, not because we can't take the square root of 0. So we have 8 minus x is greater than 0. So subtract 8, divide by negative 1, and we have x is less than 8. So my domain would be negative infinity up to 8, not including 8, because we cannot have the denominator being 0.